So we are going to do challenge yourself for chapter 14. This chapter is about the sets. So let's have a look at the first problem. We have three problems. So let's look at the first problem. So the first problem says we are given a set. It has two elements, A and A. So it is actually the second element is another set which contains A. So it has two elements. One is element A, the other is the set A. So the set S contains another set A. So state and explain whether the following statements can be true. So let's see. The first one is, we can just write down over here in front of us. So A belongs to S. So definitely A belongs to S. So this is going to be true. The second one is set A belongs to S. Set A is, so this is part of S. So this is also true. So next is, again, the set A is subset of S. So now this set A is not this element, but it's a set which contains simple A. So how many subsets of S we have? So we can list down. This is, I mean, this is not asked here, but for our understanding, remember empty set, we can write down like this, or this is subset of any set. Then we have single element sets. So its elements are this one, and the set A. Set A is also element of this. So this is also a subset, and then we have two element sets. So which is A and this A. So this is like proper subset. So if we have like this kind of thing, then we include this set. It's just this, so we don't include this one. So this is a subset of S, and this is also subset of S. So set A is subset of S, that's true. And a set whose element is another set A. So this is subset of S. So it is this case. So this is also true. So all these four statements are true. So this was question one, quite easy. Let's go to question number two. So we have a set S, it has n elements. How many proper subset does it have? So when we talk about subsets of an S, so remember we have, usually we call it power set or P of S. P of S is set of all subsets of S. And if we put these pipe signs, vertical lines, these are called pipe signs, this tells us the size of power set. So this is 2 raised to power n. N is number of elements in S, or we can write down 2 size of S. So size of S with these pipe signs. So if we have a set, for example, S has 2 elements. Let's call it A and B. So how many subsets we are going to have? Empty set, set A, set B, having just B as element, and A comma B, right? So 1, 2, 3, 4, we have 4 subsets. So 2 raised per number of elements, which is 2. So 2 raised per 2 is equal to 4. We have 4 subsets of set S. If we have 3 elements, for example, S is, let's call it ABC or XYZ. So we have empty set, then single element set. So we have A, B, and C. These are single element sets. Sets, subsets with only one element. Then we can have sets with two elements, A, B. So try all possible combinations. Remember, in sets or subsets, order doesn't matter, but we have all different combinations. So A, B, and we can have AC, we can have BC. So these are 3 sets with 2 elements. And third one is 3 elements set A, B, C, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. 2 raised to power 3 is equal to 8. You know, it's quite straightforward. If we add one more element, S is equal to A, B, C, D. So what happens now? So D is attached to all these elements. So whatever are subsets of this new set S, it contains all these 8 elements as subset. This will be part of this ABCD set. But on top of these, we will have D associated with each and every subset of this previously listed subsets. For example, phi, and we append D to it, so this become like D, right? A, so we put D with this, so it will be AD. Similarly, we can have BD and CD. And then we can append D to these 2 element sets, so these become 3 element set, A, B, D, and A, C, D, and B, C, D. The last one is append D to this ABC. So A, B, C, D. So total how many sets we got? 8 of these and 8 of these. 8 plus 8, 16. Or in other word, we can write down 2 raised per 4 is equal to 16. Or you can write down like 2 into 2 raised per 3. Whatever we have got previous. So 8 of these and 8 of these. 2 into 2 times 2 raised per 3, which is 2 raised per 4, which is 16. So whenever we have power set, the power set is a set which contains all proper subsets of a set. Whenever we have got power set, number of elements in a power set is 2 raised power number of elements in the set, 2 raised power n, right? So if a set S has n elements, so how many proper subsets we have? 2 raised power n. If they are, for example, we got a set with so this is called cardinality or size of S. It has 10 elements. So number of subsets is 2 raised to power 10. We have got 1, 0, 2, 4 subsets like that. This was question number 2. Let's move to question number 3. This is about drawing a Venn diagram. We have got a number of shapes, quadrilaterals, square, rectangle, rhombus, parallelogram, trapezium, kite. And we have to do classification, like which quadrilateral lies within the other one. For example, square. So we know square is a quadrilateral with all equal sides, but at the same time, it has 90-degree angles, right? So opposite sides are equal. So all sides are equal, so opposite sides are also equal, which is definition of rectangle. So it means square is also a rectangle. And similarly, we can think about like parallelogram and kite, trapezium, rhombus. So before we get into Venn diagram and do classifications, it's good to recall about all these shapes. So let's quickly recall about all these shapes. So the first shape is, this is a square shape. So for square shape, we know like square, so it has all equal sides, all equal sides, all 4 sides are equal, and the angles between any 2 sides is 90 degree. 90 degree angle between any 2 sides, any 2 adjacent sides, any adjacent sides. So this is quite strict requirement. So this is 90 degree, right? And same happen with all others. And when we have to show like some side is of same measurement, so we put like this line. This line is same as this line, is same as this line, and it is same as this line. So this is the definition of square. So now let's move to definition of rectangle. So rectangle is having all 90-degree angles, but we have some different kind of restriction as compared to square. So we say like opposite sides are equal. This is equal to this one, and this side is equal to this one. So we define like there is 90-degree angle between adjacent sides, which is the definition of a square as well, adjacent sides. And opposite sides are equal to each other. Opposite sides are equal to each other. So over here now we have come to an important result. For square, opposite sides are also equal. Not only opposite sides are equal, but all sides are equal. So in a way, if we draw a Venn diagram, if this is a area for rectangle, rectangle. So square lies within a rectangle. So all squares are rectangle, right? But all rectangles are not square. These rectangles may have different length and width. So square is a special kind of rectangle. We can call, just like triangles, we can call it equilateral rectangle, a rectangle with all sides equal. So this is called square. Lateral, wherever the word lateral comes, so it means we are talking about the sides. Equilateral, a shape with equal sides. So square is equilateral triangle. So we've got one part of our Venn diagram. So rectangle and square is part of rectangle. Let's move to the next shape. So this is a rhombus. A rhombus, this rhombus we define a shape in which opposite sides are equal to each other. So angle may or may not be of 90 degree. So it could be 90 degree or it may not be 90 degree. The thing is, all sides are equal. Not only opposite sides are equal, but all sides are equal. But the angle may not be 90 degrees. So all sides are of equal length. So can we see rhombus is a square? It could be, it could not be. But can we say square is a rhombus? Yes. So square, it is a special kind of rhombus in which the angle is 90 degree. So we can have some rhombus like this. It has equal sides, but angles are not 90 degree. So now we have got rhombus and square is part of it. So square is such a special kind of shape which becomes part of any quadrilateral. So let's move to next one. So we have parallelogram. Parallelogram is quite generalized kind of quadrilateral. So parallelogram. So it names itself tells there is something about the parallel. So how we define? We define like the opposite sides are parallel to each other. So this side is parallel to this one, and this side is parallel to this one. To distinguish from this parallel, we put double arrows. So parallelogram, is it a rectangle? Yes, because for rectangle also, the opposite sides are parallel to each other. The special case is angle between adjacent side is 90 degree. In parallelogram, it could be 90 degree, it could not be 90 degree. If it is 90 degree, then it becomes a rectangle. So parallelogram is quite a generalized kind of quadrilateral in which parallelogram also falls into it. And if sorry, rectangle also falls into parallelogram. If rectangle falls into parallelogram, that then it means square also falls into parallelogram. So square is also a special kind of parallelogram in which opposite sides are equal to each other, parallel to each other, and angle between adjacent side is 90 degree. So we go to the next shape. So next shape is trapezium. Trapezium is even more generalized from parallelogram. So over here we say like at least one pair of sides are parallel to each other, like this. It could be the other two sides might be parallel to each other or might not be parallel to each other. So I should not put the equal sign. So it could be parallel or it could not be parallel. But at least one pair of side is parallel to each other. If two sides become parallel to each other, then it become parallelogram. Otherwise, this is trapezium. So for trapezium, two sides are parallel to each other. So we can have some shape, something like this, a straight line like this, and then we can have like this. So this is also a trapezium. These two sides are parallel to each other. We can have vertical like this, and we can put something like that. So this is also trapezium. This is parallel to this one. So this was definition of trapezium, and over here the last one is kite. So kite is a bit different from all of these. So kite has the two adjacent sides are equal to each other. This is equal to this one, and this is equal to this one. So this is kite. Angle over here, it could be anything. So angle over here could be anything. Usually these two angles are equal to each other. So if the lower two sides become equal to upper two sides, it become a rhombus. Rhombus is special kind of kite. So if rhombus is a kite, so is the square. Square become kite. But a rectangle cannot be a kite because in rectangle, the two adjacent sides are not equal to each other. In square, just we put like square like this, so it become a kite. So if the angles are 90 degree, then it's square. If angles are not 90 degree, then it's a rhombus. So this is kite. Now let's have a look how we put these shapes into Venn diagram. So Venn diagram, we draw one circle or blob, we can say. So over here, we put all our shapes. So this big diagram, this is our universe. So we call it, uh, yeah, this is like our universe. Universe means uh, the things about which we are talking about. We are talking about quadrilaterals. So let's call this circle for quadrilaterals. Laterals. So all quadrilaterals falls into this circle or ellipse. So now where does all these shapes lie down? So I put all these shapes into this Venn diagram. So it comes like this. So over here we have, so this is my parallelogram. Should use this one, parallelograms, right? So this is like we call a rectangle, and this could be uh, rhombus. This is square, and we can put all other shapes over here. So rectangle is square. Square is part of the rectangle, and square is also part of rhombus. Rhombus is parallelogram, but a rhombus may be a rectangle or may not be a rectangle. When it is rectangle, so I mean in that case, it's going to be square is part of it. So square lies in rhombus, it lies in a rectangle. Over here, so we have trapezium. Some of the trapezium, these are like special case in which they becomes parallelogram. Otherwise, trapezium lie here. And kite doesn't comes under parallelogram because opposite two sides are not going to be parallel to each other. However, we saw like rhombus or squares may be kite, so we can draw some circle in it. So this is for rhombus. Within rhombus, we can put a square as well. So trapezium, in trapezium, we can also put a square. Square is such kind of shape, it could be part of any of these quadrilateral. So like this. So square, I mean, it is not possible to overlap this square with this. So we put square like 3 times inside the kite, inside the trapezium, and inside the parallelogram. So for example, trapezium, there could be square, but in general, trapezium is much, there could be much different shapes. So square is just a special kind of shape, just like in rectangle or rhombus or in parallelogram. Square is shape, but there could be different kind of shapes. So this is a Venn diagram for this when we have different kind of quadrilaterals.